folks, welcome to another edition of the Luthier's Lair. Yes, and this edition is going to kick off part one of a new series, and it again is going to be a Gazzbass Quintessence build that we're going to be doing. Yeah, but this one is quite a bit different. As the name says, custom bases. Is that the right way? Yeah, custom bases. So I do allow the customer to customize the original design. In this one, the body shape's going to stay the same, but the neck profile is going to be slightly different. The electronics are going to be completely different. The pickup arrangement is going to be completely different, and the power overhead of the whole thing is going to be completely different, and the choice of woods is quite a bit different as well. So, you know, I'm really looking forward to the start of this build. I've already received the deposit from the customer to begin the build. All the parts have been ordered and I'm just waiting on parts coming in. So I think the best way to start this series off is to give an overview of what is being modified from the original Quintessence base that I built about a month ago or so. So let's go and take a look at that, shall we? Yes.
Hey folks, hope you can hear me. Yeah, I'm just doing some preliminary tests on this new build we're going to do. It's using the super glue and painter's tape method of affixing a workpiece to the CNC wasteboard. And I must admit, it's turning out really well. I want to do this for the fingerboard, which I'm going to make out of Macassar ebony. So I'm using a piece of oak right now, and I've got right down to the last tool sequence, which is cutting the fret slots, and it's working great. So let's go and quickly have a look. I'll switch the camera around here. And yeah, it seems to be working fine. You see under there. Now, you'll notice that I put tabs on there just in case on the workpiece, and I didn't glue the workpiece down in the optimal spots, but it's doing a good job so far, so I think I'm going to go with that. Yeah, so quite happy with it. I think this will be the way I make fingerboards from now on. The good thing about it is that you don't need clamps. And clamps take up room, so you need to get oversized stock in order to do any work on anything. So yeah, this probably makes much more fiscal sense for me. And of course, with regards to electricity, with a fingerboard, I really don't need to put a dust extractor on. I can just vacuum when I need to, because CNC machines create chips, not dust. Anyway, well, that very fine tool I have in there to cut the fret slots kind of create dust. But anyway, cool, right? Okay, actually the first thing I want to address here, just before we go into the rundown of stuff we're going to use, is I had a request to be selective between 9 volts and 18 volts. You have two 9-volt batteries here. They're not the same make. They should be the same make, but I am, because the internal resistance of different brands of batteries are different. They vary, so you might get one lagging behind the other. If I've got them like in parallel, you know, one load might be different than the other. You're going to get overheating in one, so it's good to have batteries of the same brand, but for testing right now, I'm going to be using this voltmeter. Now I've got them hooked up to this double pole double throw switch, which has 6 terminals and allows you to choose between terminals when you're switching. And basically what I'm going to do, ignore the bottom half of this diagram right now, is I've wired it up like this so that I can have either 9 volts or 18 volts being supplied to the preamp in the bass guitar. Let's just see if it works. We'll switch this to DC voltage. I don't know if you can see that. It's, well, you probably can. Right, it's sitting at 9 volts approximately right now. These batteries are a little old. And if I switch that, it'll go up to 18 volts or thereabouts. And that will supply the preamp with either 9 volts or 18 volts. Now the preamp that I am going to be using in this is a Seymour Duncan STC 3M4, and it accepts both 9 and 18 volts. 18 volts for additional overhead with regard to power. So what does that mean? Well, yeah, more power consumption, more output, basically. Also, it's kind of wise to have that. I mean, I've never done it before. Most of my basses, in fact all of them, run off of, the active ones anyway, run off of 9 volts. 1 second. This AC is bothering me again. Hold on. Right. So, we now have a switching mechanism between 9 volts and 18 volts. But as you can see, there's a bounce there. It doesn't immediately go to 9 volts and 18 volts. And it never will, of course. But we have mechanical contact noise in here, so if you switch between 9 and 18 live through a big amp rig, you'll get a pop sound. So how do we mitigate the pop sound? Okay, let's just clear this out over here. Let's switch that off. We'll use a simple RC circuit here to mitigate that. Okay, so I'm going to combine this with this, and you'll get the V out and everything like that. So VCC from here will come at V out here, it'll come in here. The negative, of course, will connect down here, and then we'll connect the circuit through these terminals right there. I don't know if that's clear or not. Should I just draw it out? Do you want me to just draw it out? I can do it on a blank piece of paper here. You still probably can't see unless you're full screen there, but we have a double pole, double throw switch here. Okay. You have one battery here, one battery here. Okay, that's positive, that's negative. Okay, reciprocated. Our V out is here. Okay, our negative is here. Okay. Actually, that's wrong. Just drop that out. Our negative is here. Okay, so you've got that and that. Let's see. And there's actually a crossover connection in here so that the switches work correctly. So I'll just loop that across and put that in there. So that's the basic diagram. Okay, now what we're going to do with this is our VCC defined in this circuit here. And what we're going to have is a resistor here. Okay, we're going to have our V out here. Okay, then on this here, this is where that switch arrangement comes into place. When we reverse that, we're going to have that back down here. We're going to have a capacitor going across this, and our negative will be there. So that's basically a scroll. You can see from that. Yeah, this is all pretty well designed, and depending on the values of This is a time constant circuit, so you'll get a very small delay between switching from 9 to 18 volts for power consumption, because the capacitor has to charge up based on this resistor value in order to output the signal. So you get a very small delay. You can do this with an Arduino as well, but yeah, when that happens, you don't get that instantaneous change of voltage which creates the pop. You get a smooth transition. You can also use something called a Schmidt trigger in electronics that will do the same thing. So yeah, awesome, right? Electronics 101. Okay folks, hiya, hi. Yeah, let's do a quick rundown of what we have so far in stock, and I will be starting the actual build today at some point. First off, let's remark on the woods. This is a beautiful piece of maple that I just got in from Warmouth Guitars. They supply my maple because I know it's straight and true and just gorgeous piece of maple here, and this is going to be for the neck. Absolutely beautiful piece of maple, very solid, very sturdy. Usually only use a truss rod in these necks, and here's my dual action truss rod, 24-inch dual action truss rod for the base. But per customer request, first time I've actually done this, so I'm going to put 2 carbon fibre reinforcement rods in the neck just for added stability per customer request. So I'll draw that up today as well, and we'll get a G-code program made for the CNC machine to do that, because the neck's getting completely made on the CNC machine. Excuse me. The body will be done entirely by hand. And speaking of the body, here's one of the wings, which is a highly figured piece of black limber. There's the other one there. Some scuff marks on it there, but this is going to get planed down. And it will also be covered on the front, which I'm waiting on. Is it's going to have a burl olive top. It's going to be striking. The burl olive's about 4mm thick. It's so rare in the US that I couldn't source the right size in the US, so I had to import it from Turkey, believe it or not. I had to import this piece that I really liked from Turkey. So that's cool. That should be coming within the next week. But I can get all these planed down to size, and then the centre piece is going to be like the original Quintessence base. We'll have 1/4 inch maple here, 3/4 inch walnut, 3/4 inch maple, 3/4 inch walnut, and once again 1/4 inch maple on the outside, making a 3-inch centre piece across. And to top off the wood selection, the customer has requested that I do a front mounted control plate, 1/4 inch thick, and this is a walnut veneer with a maple trim for the control plate. So this is just an experimental piece. I might play about with this a little bit more, I'm not too sure, but we'll see. And some hardware has also come in. Because this is only going to have one pickup, I'm going to have room for a proper battery box and not a battery cavity. So and why two batteries when there's no LEDs going in the neck? Well, I made up a little circuit here that will switch between 9 volts and 18 volts for additional overhead in the power supply to the preamp, which will be here tomorrow, and I'll show you that. And of course I've got a debouncing circuit on here so that when you switch the switch it doesn't pop. You know, you don't want it going pop pop as you switch it.
some switches in here. Going to be using one for the pickup, which is going to be wired in both series, split and parallel. So series, single, parallel is the three modes that the pickup is going to be in. That's exciting. Nice jack plate here, although I don't know if this design will accommodate it. I'll maybe mess around with this. If not, I'll just mount it the usual way that I do, which is also fine. No problems. And the Hipshot kick-ass high mass 4-string bridge from Hipshot, of course. Never let me down. Variable string spacing, plenty of room for intonation. Very solid piece of hardware. You can't go wrong with these bridges. They're fantastic. Beautiful resonance of the string as well. We have a nut, a brass nut this time. I was going to go with tusk, but I wanted it to make it more like a kind of a Spectre type design of nut at the neck there. So it's going to be brass in keeping with all this. And I have the dot inlays, which are abalone dot inlays for the neck, and they get installed while the neck's being machined during tool changes. So that's a lot of fun. We'll show that later on as well. So that's all I've got right now coming in. I still have the the preamp to come, the tuners to come, bunch of other little bits and pieces to come, but that's what we got so far. So I think it's time to start this build. What do you think? Cool. Well folks, that's all we got time for part one of Project Jonas, or Jonas. My customer wanted this project to be named after Jonas Hellborg, the great Scandinavian bassist. He being a hero of the customer, so I thought that was a really good idea, and paying a little bit of homage there to a fine bass guitarist. Anyway, if you like what's happening on this channel and you watch a lot and haven't subscribed yet, please consider doing so. Really helps me out. Give me a thumbs up and hit that bell for notifications of any further upcoming uploads for your delectation. Yes. Until then, all that remains for me to say is stay safe, be good, and we'll catch you next time in part two, where we'll actually start building stuff. Okay? Take care. Thanks again for watching. Cheers. Bye-bye.